All right, guys, so a series of short videos here today. Okay, we're going to have part 4 here. This is going to be the last question for this lesson, okay? We have this function, okay, and we've seen questions like this up before. We're just going to use this new information of what a turning point is, okay? So what we're going to see here is, here's what we got, okay? So we can always, remember, you guys can, you have this newfound knowledge of this derivative, right? And so you can, the nice thing about the derivative, when I apply the derivative, is it eliminates variables. Okay, so we can use that. Okay, so we can say f prime of x is going to equal 3x squared plus a. Okay, I would start with that, and then from there, you can use this idea of what the turning point is. Okay, we know that, like we saw up top here, okay, 0, 0 is what we call a turning point. Okay, we identified the fact that it was an important value, okay, but it was neither a maximum or a minimum. Okay, but it would have identified, it still came out of the fact that the derivative, it set the derivative equal to 0. Okay, so we still have that in our back pocket as a tool, right? So we know at this turning point, f prime of x is equal to 0. We know that. Okay, the derivative is equal to 0 there. Okay, so if we use that, we know that this is equal to 0. So we know at f prime at -2 is going to equal 0. Okay, so if I plug in the fact of -2 into our derivative function, I can say, okay, well, f 0 equals 3 times -2 plus a. Oh, -2 squared, sorry. Right? And so I'm going to see that we're going to get 0 equals 3 times 4, and a is going to equal -12. Okay, we're using the fact that this is a critical point. It's a turning point. A turning point is a critical point. We're going to spend more time on that this afternoon. Okay, but this would be how you would navigate a question like this. Now, we found one of the values, so we could plug that in. A critical point, it lies on the original graph. It told you that it was a turning point on the original graph, right? So we can jump over and use the original f of x function. F of x is equal to x cubed plus ax plus b. Now, this point, you have an f of x value. F of x is going to equal 6, right? And remember, the x value is going to be -2, right? So 6 will equal -2 cubed plus, well, you found what a was, so why don't you put it in there? -12 times -2 plus b. Okay? All this stems out of the fact that this is identified as being a critical point, right? They're points at which the derivative is set equal to 0. Okay? You'll notice here, like it's an interesting, right? You plug in 0. There's no denying the fact that when you plug in 0 into this function, the derivative gets set equal to 0. But it doesn't look like the slope is 0. That's what makes it interesting. Okay, we're going to spend some more time on that this afternoon. Okay, so here's what we got. So now, this looks like I got one thing to solve for. -2 cubed will be, so we'll get -8, and then plus 24, right, plus b. And if you were to solve for this, you would see that b would come out to be 10, -10, sorry. Okay? So now we can say, therefore, a is equal to -12, b is equal to -10, and the function f of x is going to look like x cubed minus 12x minus 10. Okay, guys, that's going to wrap up this lesson. Hopefully you don't mind having a whole bunch of shorter videos instead of one really big long one to watch. I'll embed them all into Minds Online, okay? Again, the most important thing is that we're using this idea of critical points and expanding upon the fact that critical points don't need to be maximums or minimums. They can be something else. They can be values, like turning points in this instance, where the derivative is set equal to 0, okay? And we're gonna prove that this afternoon a little bit more, okay? So that's that. Disregard these questions, sorry. Okay, these are from a different textbook that I don't have access to, or it's at least the one I didn't use in high school, okay? So I have all your questions picked out already. So don't worry about that. Everything's posted on Minds Online for you, okay? So that's that, guys, okay? And we'll see you this afternoon.